Intelligence Gateway.
Module 4, Computer Vision. Computer vision is a field of artificial intelligence (AI) and computer science that focuses on enabling machines to interpret and understand visual information from the world around them. It involves developing algorithms and models that can automatically analyze, process, and recognize images and videos. Computer vision has a wide range of applications in various fields, including healthcare, manufacturing, automotive, retail, and security. Some of the most common applications of computer vision include 1. Object detection, identifying and localizing objects within an image or video. 2. Image classification, assigning labels or categories to images based on their content. 3. Facial recognition, identifying and verifying an individual's identity based on their facial features. 4. Optical character recognition, OCR, extracting text from images or documents. 5. Autonomous vehicles, enabling self-driving cars and other autonomous vehicles to perceive and navigate their environment. To achieve these tasks, computer vision algorithms and models rely on a range of techniques, including image preprocessing, feature extraction, deep learning, and convolutional neural networks (CNNs). These techniques enable machines to interpret and analyze visual information from the world around them, making it possible to automate a wide range of tasks that were previously performed by humans. Overview of computer vision and its applications. Computer vision is a field of artificial intelligence that enables machines to interpret and analyze visual information from the world around them. It involves developing algorithms and models that can automatically analyze, process, and recognize images and videos. Computer vision has a wide range of applications in various fields, including 1. Healthcare. Computer vision is used in medical imaging to assist with diagnosis, as well as in telemedicine to enable remote consultations. 2. Manufacturing. Computer vision is used in quality control and inspection to detect defects in products and ensure they meet certain standards. 3. Automotive. Computer vision is used in advanced driver assistance systems (ADAS) to enable self-driving cars and other autonomous vehicles to perceive and navigate their environment. 4. Retail. Computer vision is used in facial recognition and object detection to personalize the shopping experience and detect theft. 5. Security. Computer vision is used in video surveillance to detect and prevent criminal activity. To achieve these tasks, computer vision algorithms and models rely on a range of techniques, including image preprocessing, feature extraction, deep learning, and convolutional neural networks (CNNs). These techniques enable machines to interpret and analyze visual information from the world around them, making it possible to automate a wide range of tasks that were previously performed by humans. Module 5, AI Tools and Platforms. AI tools and platforms refer to a set of software or hardware systems that are designed to support the development, deployment, and management of artificial intelligence applications. These tools and platforms typically provide a range of features and functionalities to facilitate the creation of machine learning models, natural language processing systems, computer vision systems, and other types of AI applications. Some common examples of AI tools and platforms include 1. Machine learning frameworks and libraries, example, TensorFlow, PyTorch, Scikit-learn, that provide a set of pre-built algorithms and tools for training and deploying machine learning models. 2. Natural language processing platforms, example, Amazon Comprehend, Google Cloud Natural Language API, that enable developers to build applications that can understand and analyze human language. 3. Computer vision platforms, example, OpenCV, Microsoft Computer Vision API, that provide tools for building image and video processing applications. 4. Chatbot development platforms, example, Dialogflow, BotPress, that enable developers to build conversational interfaces that can interact with users in a natural way. Overall, AI tools and platforms play a critical role in making AI more accessible and easier to use for developers and businesses of all sizes. Overview of popular AI tools and platforms. There are many popular AI tools and platforms available today, each with its own set of features and capabilities. Here are some of the most widely used and well-known AI tools and platforms. 1. TensorFlow. Developed by Google, TensorFlow is an open-source machine learning framework that allows developers to build and train machine learning models using a variety of programming languages. 2. PyTorch. Similar to TensorFlow, PyTorch is another open-source machine learning framework that offers a more flexible and intuitive interface for building and training machine learning models. 3. Keras, a high-level API built on top of TensorFlow. Keras offers a simple and easy-to-use interface for building and training deep learning models. 4. Scikit-learn, a popular machine learning library for Python. Scikit-learn provides a wide range of algorithms and tools for building and evaluating machine learning models. 5. Microsoft Azure Machine Learning, a cloud-based machine learning platform. Microsoft Azure Machine Learning allows developers to build, train, and deploy machine learning models using a variety of tools and services. These are just a few examples of the many AI tools and platforms available today. Each platform has its own strengths and weaknesses, and developers should choose the one that best suits their specific needs and requirements.
Thanks for watching. For more information, like, comment, and subscribe our channel.